Specific heat capacity. The specific heat capacity is defined as the amount of energy required to raise 1 gram of a given substance 1 degree Celsius. And it's different for each substance, and it's different for what phase they're in. The fact that it's a unique value for any particular substance means that the transfer of an identical amount of energy to the same mass of two different substances will not result in the same temperature change of the substance. The amount of energy transferred, Q, that's how we represent heat, or energy transfer, can be related to the temperature change of the substance, delta T, by the equation Q equals mc delta T. C is the specific heat capacity, and it just depends on the substance and the phase it is. So for water, it's 1 calorie per gram degree Celsius, which is 1 calorie, or 4.184 joules per gram degree Celsius. M is the mass of the substance. The more substance that you're heating up, the greater the heat needed to do that. And if you're going to change the temperature larger, then you're going to have more heat. So Q equals mc delta T. It's an important equation. You should probably memorize that one. Note that C is a constant for a given substance. Once again, we have a list of several things here of specific heats in joules per gram degrees Celsius. Sometimes you'll see molar heat capacities where joules per mole degrees Celsius. Note that the heat capacity sometimes you'll see is capital C's, and this is for a given item. It doesn't depend on the grams, it's just the whole item. Normally you see this when we're doing calorimetry, and you'll find the C for the calorimeter, which is the item that you put your reaction or your items into to figure out how much heat is gained or lost by that calorimeter.